Welcome friends to this new lecture of soil science and technology, and today we will be discussing about soil texture and its classification. And what is soil texture? We will talk about its definition, what are the different types of soil textural classes, what is USDA soil textural triangle, how to use that textural triangle, and then we will be also discussing about soil structure, which is a very important soil property, and what are the different types of soil structure, and what are the factors which affect soil structure and how we can manage soil structure. So, in this lecture I will try to give you a basic overview of soil texture and structure, and obviously if you want to if you want to go for a further define more advanced advanced studies of soil texture and structure, you can obviously consult any standard reference book or any standard books like The Nature and Properties of Soil written by Brady and Will. So, let us start with the soil texture. Now, you know that the definition of soil texture says it is a relative proportion of soil separates, that is relative proportion of sand, silt and clay in the soil. And remember that it is a basic and very hard to alter a property. So, this property is more or less it is constant and you cannot change this property. Now, in the first lecture of soil, I have already told you about there are three major soil separates in the soil, which are basically sand, silt and clay. And as you know, according to the USDA particle size range, the soil sand particles has diameter of 0.05 to 2 millimeter, whereas silt contains 0.002 to 0.05 millimeter diameter, whereas in case of clay the diameter of the particle is always less than 0.002 millimeter. So, based on this classification, and each of these soil separate has their own significant properties. So, let us discuss what are their what are their intrinsic properties. So, in this table if you can see first as far as the size is concerned, we have already discussed it. The second important point is feel. So, if you feel if you rub the soil which is if you rub the soil in between your thumb and finger, you will see that the sand will feel very gritty, and silt will feel like smooth and silky in nature, and clay will be very sticky in nature. So, as far as the pore size is concerned, obviously the sand particles, the sandy soil mainly contains higher amount of larger pore space, we call them macropores. And in case of silty soil or in case of silt, you will see that the pore size is smaller than that of sand. However, in case of clay, the pore size is very small. So, in other words, sand mainly contains macropores, whereas whereas clay mainly contains micropores. So, another important property based on this pore size is water and nutrient holding capacity. So, in case of sand, the water and nutrient holding capacity is very low. In case of silt, it is more than sand. However, in case of clay, it is high, but releasing capacity is low. Because of huge amount of water holding, high amount of water holding capacity of clay, the water cannot move freely within a clay soil. However, it can move freely within a sandy soil, but its holding capacity is very less. Another important property is specific surface area. So, in case of sand, obviously the specific surface area is very low because of larger particle diameter, and in case of silt it is large. However, in case of clay it is very large or tremendous high specific surface area, and we will discuss that very soon. So, this slide shows basically the changes in specific surface area as we go from gravel to sand to silt and clay. Now, you can see from this in the x axis we are plotting the particle size or width of each cube. If we are considering each soil particle as a cube, and if we are going from gravel to sand to silt and clay, you are seeing that the particle size is reducing from 10 to 1 to 0.001. So, we are starting from gravel and we are going towards the clay. So, particle size is continuously going down. So, as the particle size continuously going down, you will see that specific surface area, which is measured in terms of square millimeter per gram, is continuously increasing in this direction. So, obviously, for example, if we consider a volume, if a sand particles with 8 millimeter, or is a gravelly particle with 8 millimeter 8 millimeter particle particle size, then we will have a total volume of 512 cubic millimeter. However, and if it has mass of 1.3 gram. Now, once we break down this big cube into individual very small cube, ultimately you will see the total surface or specific surface area is increased, because the internal surface area here will be also available. So, these will add up to the specific surface area, and obviously as you see that as we are going from higher particles to the lower particles, I mean lower size particles, there is a exponential, almost exponential increase in specific surface area, and obviously as the specific surface area increases, the adsorption, swelling, plasticity and heat of wetting, all these increases. So, that basically shows that once when we go from sand to silt to clay, obviously their specific surface area increases, and as a result of the increase in specific surface area, the adsorption, which is a surface phenomena, and swelling, plasticity and heat of wetting, all these properties generally increases. All right. So, importance of specific surface area, as you can see from this slide, that when there is a small particle, obviously there will be more, when there will be small particle, there will be more specific surface area, and when there will be more specific surface area, there will be more water holding capacity. In case of clay, as we have already discussed, that it has got high water holding capacity, and it is because of it has got high specific surface area because of small particle size. Also, due to the small particle size and due to the higher specific surface area, you will see that more nutrient holding capacity, as we can see generally in case of clayey soil. Also, due to the higher specific surface area, you will see that more area for weathering, and obviously more nutrient released by the weathering. So, this is another importance of specific surface area. Another importance of specific surface area, that when there is a higher specific surface area, obviously there will be more ions in surface, and more the soil will stick together as an aggregate. So, this is the implication of specific surface area, and more specific surface area will also helps in more chances of microbial activity. So, these slides basically shows in a in a comprehensive way that importance of specific surface area, and obviously these changes in specific surface area is very much apparent when you go from sand to silt to clay particles. Now, soil textural classes. So, soil textural classes convey an idea of size distribution of particles and the general nature of their physical properties. So, based on the textural variation of the soil, we have divided the soil into 12 textural classes, and these 12 textural classes are depicted by using a textural triangle. So, let us see what is a textural triangle. So, textural triangle, as you can see, this is a textural triangle, we call it USDA textural triangle, and in this textural triangle you can see there are 12 different textural classes. So, what are these textural classes? As you can see, it starts from clay, it starts from clay, and also silty clay loam, silty loam, clay loam, sandy clay loam, sandy loam, loamy sand and sand. And as you can see, in each of the sides of this textural triangle, they the percent of silt is distributed in this side, and percent sand is distributed in this side, and percent of clay is distributed in this side. So, starting from 0 to 100%. And remember that all these percentage of sand, silt and clay all adds up to 100%. So, if we know only 2 of them, you can obviously calculate the third one. Alright. So, based on that also, I mean, there are general terms which we use for describing the soil texture in relation to the basic soil textural classes. So, as you can see here, when the soil belongs to the sands and loamy sands, we call them coarse texture soil. When they belong to the sandy loam and fine sandy loam, we call them moderately coarse soil. When they belong to very fine sandy loam to silty loam to silt, we call them medium textured soils. And when they vary from sandy clay loam, silty clay loam and clay loam, we call them moderately fine, and fine are basically consist of sandy clay, silty clay and clay. So, based on the dominance of clay and sand, obviously we can separate the soils into coarse texture and fine texture soils. So, obviously sandy soils are generally coarse texture in nature, whereas the clay soils are generally fine in nature. Okay. So, let us see how to use the soil textural triangle. So, let us consider an example where there is 30% clay, 20% silt and 50% sand. So, how to use the USDA soil textural triangle to measure or to determine in which textural class our soil belongs. So, we will start from here. So, let us start with the percent silt. So, here we can get the percent let us start with the clay. So, there is 30% clay. So, we will start from here. So, 0% clay, 20% clay and 30% clay. So, at the 30% mark we will draw a parallel line. As you can see here, this is a parallel line which is along with the percent sand side. So, this is the first step, and in the second step we know there are 20% silt. So, we will draw another parallel line to the clay axis to this is a blue green color line you can see here, and you can see both of them are intersects at this point. And if we go further and we know there are 50% of sand, then we can draw another line which is parallel to the percent and percent clay. So, you will see that all the 3 lines will intersect at this point, and basically this point belongs to sandy clay loam. So, based on these we can define that our soil, the given soil sample belongs to sandy clay loam soil texture. So, that is how we use generally soil textural triangle. Now, how to use the soil texture, how to feel or how to determine the soil texture? Well, there are a couple of ways to determine the soil texture. One of the more most qualitative way is field method. So, basically the soil scientists generally go to the field and take the soil in between their thumb and fingers, and they just rub it and they just try to feel it by rubbing in between the fingers. So, and also try to form or try to mold them into different shapes. So, based on that they can say whether the soil belongs to a sandy, belongs to a silty soil or loamy soil, or ultimately to a clay soil or not. So, there are some texture, there is some there are some well defined criteria for classifying the soils into different soil textural classes. As you can see here, this shows basically shows the flow chart which generally we use for identifying the soil through field method. So, this basically gives a very good idea about how to use the field method for determining the soil texture. For example, let us start by moistening and kneading the soil into putty like consistency and try to form a ball. So, this is our first step. So, the second step says, okay, can the soil be formed into a stable ball that does not fall apart? So, if it is no, if the answer is no, obviously this soil belongs to sand class. So, that means the soil cannot be formed into a ball. So, obviously, this is sand. If it is yes, then we will go to these steps. So, the second question will come, can the soil be squeezed into a ribbon? If it is no, obviously, it will be loamy sand, because due to the presence of sand, the plasticity nature of the soil is very, very low. If it is yes, then it will go to the further decision making question. So, based on this flow chart, you can literally differentiate different types of soil texture. For example, you can see here they are trying, one soil scientist is trying to form a ribbon using a by kneading a soil, and obviously you can see the type of the length of the ribbon is always less than 2.5 centimeter. So, obviously that belongs to loamy type of soil, and there is when this ribbon size is 2.5 to 5 centimeter, the types of it shows the types of clay loam, and when the size of the ribbon is greater than 5 centimeter, it shows the type of clay. So, based on this size of the ribbon, or and these decision making criteria, you can literally classify different soils into different soil textural classes. For example, in case of sand, it will feel gritty, and it will basically it considered non-cohesive, because it does not stick together in a mass unless it is very wet. In case of silt, it does not feel gritty, but it feels somewhat floury and smooth like silly putty in your hand when you rub it. And finally, when in case of clay, when it is very sticky when it is wet, and also it is very much plastic, or it can be molded readily into any shape or rod. So, clay shows this type of characteristics, and also you can use the clay for easily form ribbons, which you cannot do with in case of with sand and silt. So, how we generally determine soil texture? Well, there are a couple of ways we generally determine soil texture in the lab. All these are quantitative in nature, and the classical sedimentation method is basically used in the lab, and generally we have divided that classical sedimentation method into two major methods. One is called pipette method, and the second is hydrometer method. So, both of these are based on the sedimentation principle and based on the Stokes law. We will discuss the Stokes law in the next slide. Remember that the soil dispersed using chemical agents and allowed to basically to sediment and to settle down, and obviously the particles settle down based on the principle that the bigger they are, the faster they fall. And obviously, these two methods are very much time consuming methods and very much laborious methods also. So, nowadays soil scientists are measuring the laser diffraction, measuring the soil particle size or soil texture using laser diffraction method, and we call it laser diffraction particle size analyzer. It is very much fast and precise, but sometimes it is underestimates clay. So, that is one of the drawback of this laser diffraction particle size analyzer. Now, obviously, in this picture, as you can see that based on this principle of sedimentation, obviously, if we disperse the total soil using some dispersing agent, obviously, at first the coarse sand will settle down, followed by fine sand, silt, and obviously clay will remain in the solution. So, based on their diameter or based on their size, they will settle down, and this is the principle which is used for pipette and hydrometer methods. And this is a picture of LDPSA, which is more precise, and this is laser diffraction particle size analyzer, and it is very much costly instrument also. So, let us discuss about the Stokes law. Now, Stokes law basically says the settling velocity of an particle in a liquid, and if we denote that settling velocity by V, it is basically proportionate to the diameter of the effective diameter of the particle and gravitational force, which is denoted by G, and the difference between the density of the solid particles and density of the fluid, and it is inversely proportional to the viscosity or thickness of the fluid. So, here d is basically the effective diameter of the particle, and g basically shows gravitational force, which is 9.81 Newton per kilogram, and eta is basically viscosity of water, which is measured in terms of 1000 Newton seconds per square meter, and ds is the basically density of solid particles for most of the soil, which is 2.65 megagram per square per cubic meter, and density of fluid is 1 megagram per cubic meter. And substituting these values into equation, we can write this is V equal to h by t, where h is the distance and t is the time. And obviously, when you simplify, we will get it, we get to this k d square, where k is a constant. So, in other words, the settling velocity of any particle through a liquid is proportional to its diameter. When there will be higher diameter, obviously in case of sandy particles, obviously they will settle more faster than that of clay particles. So, based on this Stokes law, this hydrometer and pipette method has been both were developed, and both were used for quantitative estimation of soil texture. We also call it particle size analysis. All right. So, what is the importance of soil texture, by the way? The soil texture basically determines the water holding capacity of the soil, and it impacts the soil erosion. Remember that well drained soil allows good aeration, and sandy soil will allow good aeration, whereas clay soil will not allow good aeration. I mean, sometimes because of macropores which are present in the case of sandy soils, they allow good aeration, and it also affects the degree to which the soil is susceptible to erosion. Obviously, sandy soil will be much more susceptible to erosion than clay soil, and it also affects the organic matter levels in the soil. Generally, we have seen that there is a coexistence between high amount of clay and organic matter in most of the soils. So, also so that means the soil texture also determines the organic matter levels in the soil sometimes. Now, let us start with the soil structure. So, what is soil structure? Soil structure is another important property, which basically is the arrangement of the primary soil particles or sand, silt and clay and other soil materials into discrete aggregates. And soil structure can be differentiated or described in terms of either type, either relative size or pairs, or grades. So, type or shape of the pairs, type basically shows the shape of the pairs. What is paid we will discuss later on. And also relative size of the pairs, we call it class, and grades and relative class relative size or class of pairs is basically divided into fine, medium or coarse, and grades or degree of development of pairs, which are basically strong, moderate and weak. So, let us discuss what is pairs. So, pairs are structural units which have distinct boundaries and well defined planes of weakness between the aggregates. And as we can see that pairs consist of primary particles, remember, and they are bound together by different cementing agents like organic matter, like clay and hydrous oxides of iron and aluminum. And also pairs can take several shapes. So, if you see here in this first picture, you can see the individual particles, that is sand, silt and clay, they stick together and aggregate together to form a paid, which is an aggregate, and also pairs are stacked around each other to form a total soil structure, and this is the actual picture of soil paid. Now, what are the different shapes of the pairs? So, types of soil structure is basically depends on the shapes of different pairs. So, paid shapes are differentiated into granular and crumb, and we collectively call them spherical structure and blocky structure, prismatic structure, columnar, platy, single grained and massive. So, let us see them one by one. Let us start with the granular structure. Remember that the granular structure resembles with the cookie crumbs, and it is usually less than 0.5 centimeter in diameter, as you can see in these pictures. And these granular structure are commonly found in surface horizons where roots have been growing. So, this type of structure is very much they are very much favorable for growth of the plant, because they can they allow the easy water movement and air and water movement. There is another structure called crumb structure, and crumb structure is a granular structure with more porosity. So, obviously granular structure has their high porosity, but crumb structure is another type of granular structure which has got more porous. So, both of them are termed as spheroidal structure, and both these structures are very much helpful for plant growth. The another structure is called blocky structure, and blocky structure basically consists of irregular blocks that are usually 1.5 to 5 centimeter in diameter, and it can be differentiated into angular blocky or subangular blocky based on the angle of different sides or different planes. So, as you can see here, this shows the blocky structure. You can easily see here this is a blocky structure, and obviously these blocky structure are differentiated, as I have told you that blocky structure can be also differentiated into angular blocky and subangular blocky. As you can see here, the angular blocky are more plane. However, in case of subangular blocky, the planes are generally curved or not plane, I would say. So, blocky structure are generally of two types. So, let us see what are the other structures. Another structure is called prismatic structure. As you can see, it is a prism like and prism shape, and these are basically vertical columns of soils that might be a number of centimeter in length, and they are generally found in lower horizons of soil. As you can see here, these are prismatic structures. Another structure name is columnar structure, and columnar structure are the vertical columns of soil that have a salt cap at the top, and these columnar structure you can see in arid climates. Platy structure is basically composed of thin and flat plates of soil that lies basically horizontally, as you can see, and usually found in compacted soil. Generally, due to the heavy machinery operation over the soil surface, this type of structure generally occurs, and this type of structure are not very much favorable for the growth of the plant, because it restricts the water and air movement. Another type of structure is called single grain structure, where the soil is broken into individual particles that do not stick together. And obviously, you remember that always accompanies the loose consistency, as you can see in this picture, and you can see this type of structure in sandy soil. Another structure is called massive structure. Now, massive structure has no visible structure, and it is hard to break apart and appears in very large clods. As you can see, the clods are formed, and this type of structure you can basically see in rice field due to the puddling and subsequent drying of the soils. So, these massive structure also does not have any clear planes, and they are not well defined actually. So, we have completed the types of soil structure. Now, let us see class of soil structure. Obviously, the class of soil structure depends on the size of the pits, and they are differentiated into fine, medium and coarse. Now, obviously, a question comes that how does structure affects water movement into the soil? Well, in soils with good structure, the pore space that occurs between pits are relatively large and facilitates water and air movement. However, well developed structure is very important in clay soils, because clay soils with poor structure restricts water and air movement. So, it is always required to improve the structure of clay soils, and we can do that by different methods, different management practices. One of them is addition of organic matter. Another important aspect of soil structure is degree of water movement. As you can see here, I have shown here 6 different types of structure, starting from single grain, blocky, platy, granular, prismatic and massive. And as you can see, this single, the water movements, how it varies from one structure to another structure. Obviously, in case of platy structure, due to the platy and compact nature, water movement will be very much slow, and in case of blocky structure, it will be moderate, and in case of single grain, it will be rapid in nature. And also in case of massive soil structure, it will be very much slow. Generally, we found it in rice soils. Prismatic structure, I mean, it will be moderate flow, you will see moderate flow, and granular structure, which is very much helpful for plant growth, you will see rapid movement of water. So, as you can see, based on the soil structural classes also, you can the water movement varies significantly. Okay. So, can we alter the soil structure? Is it possible? Well, unlike the soil texture, structure can be altered by tillage. As I have already told you, texture cannot be altered, however, structure can be altered by tillage. And tilling soils that are too wet or compacting soils with heavy equipment can break down the natural structural units. And we will discuss that effects when we will be discussing about tillages. And remember that soil texture can be obviously changed by implementing different types of management practices, and one of them is incorporating huge amount of organic matter. So, altering of soil structure is possible. Now, let us see some description of field soil structure. As you can see here, these are individual blocky bed, and this is an example of weak medium angular blocky. So, it shows a combination of both type, class and grades of soil structure while defining a soil structure. Then it is a strong, very coarse and prismatic structure. Remember that hierarchical organization of soil aggregates is very important, and it is the characteristics of most of the soils, because even the smallest particle turns out to be aggregates made up of numerous primary soil particles. As you can see from here, the smallest particles turns out to be the aggregates made up of numerous primary soil particles. And this slide shows how primary soil particles aggregate together to form a soil structure. So, we generally starts with primary particles like sand, silt and clay, humus. So, these primary particles form the sub micro aggregate by adding by the cementing action of plant debris coated with clay, and also different microbial aggregates. So, basically soil is encrusted with microbial debris and plant and microbial debris. In the third step, it will form micro aggregate, and in the micro aggregate you will see both root hairs, hyphae and polysaccharides, which are acting as a cementing agents, and finally you will see macro aggregates. The micro aggregates will form the macro aggregates by interconnection of roots and hyphae. So, you can see from primary particles to macro aggregates, different types of binding agents are responsible, and that shows how these primary soil particles shows hierarchical organization to form a macro aggregate. Grades of soil structure, obviously terms weak, moderate and strong are used to describe the grades or how stable the beds are and how hard they are able to be break apart. So, based on this we can differentiate we can term what is the grade of soil structure. So, it is my final slide. So, as a summarily we can say that texture is basically the size of brick used. If you are making a house, the texture is basically the size of brick used, and structure is basically the arrangement of bricks. Or house represents, if the house represents a soil structure, then hallways, doorways and windows in the house represent associated pores and channels. So, soil texture and structure thus very important soil physical properties. Thank you.